Hi, so my name is PV and I'm here to give a brief introduction about AWS. And today the agenda is we are going to cover introduction of AWS and then compute service, storage service, database service, networking and security. So these five and innovation with AWS in the next step. So the innovation at AWS, we are going to talk about IoT, ML, blockchain, AWS ground station, AWS wavelength. So the introduction of cloud. So before going to the AWS introduction, let's understand about cloud. So computing enable you to stop thinking your infrastructure as a hardware, instead the focusing on the software. So as a programmer you need more resources, so you don't need to think about resources, and dynamic it has dynamic ability as much as you go and as much as you pay. What's other advantage of AWS? So these are the six major advantage. Trade upfront expenses for variable expenses, benefit from massive economic scale, stop guessing the capacity, like if someday you need more capacity, someday not, so you don't need to think about much, increase the speed and agility, stop spending money on running and maintaining data center, go global in a minute. In a comparisons on premises versus AWS. So on premises, you maintain server, you maintain storage, you maintain database, you maintain application, and from here is the corporate network they use. On cloud, you are sitting on internet, everything AWS will maintain: server, storage, database, application. So let's talk about the four things. Comparison with on-premises versus AWS. So in terms of storage and database, so in on-premises we have DAS, SAN, NAS, and RDBMS. So here AWS DAS to Amazon EBS, Amazon, and for SAN they have EFS, and NAS they have Amazon S3, and RDMS they have Amazon RDS. On premises server, they have AMI and Amazon EC2 instances. Networking on premises, we have router, we have networking pipeline, we have switch. So in AWS, we have elastic load balancing and Amazon VPC. On security side, on premises, we need firewall, ACL administrator. Similar to AWS, have security groups, network ACL, and AWS IAM. So key service area: compute, storage, database, network, security, as I said. So as a user, they go through virtual private computer or VPC, and then they can either go for Amazon S3 depending upon data. You can go Amazon DB, Dynamo DB, or Amazon EBS. Elastic block storage, Amazon S3, and Amazon Dynamo DB. How does it work? AWS own and maintain the network in connected hardware. You provision and you what you need to use. So if you have AWS, Amazon, the console, you can go through AWS and then AWS management console, and from that it connect storage, database, business application, compute, network, content, and internets on the things. So cloud deployment modes, there are three deployment modes. On premises, your application you need to deploy on your premises. Hybrid, you need to deploy in the both cloud as well as on premises. Cloud, only you need to deploy on the cloud. AWS global infrastructure. So if you see here this diagram, you see the first one is a data center, typically house 1,000 of servers. So and availability zone, which we call SZ. So one and more data center designed for fault isolation, and SZ region. So APAC, Southeast Asia, one Singapore, SZ A, SZ B, SZ C. So each AWS region made of two or more than SZ. AWS has 25 regions worldwide as of 2021. So AWS global infrastructure current region, choose the region, data governance, latency, cost, edge infrastructure, Amazon CloudFront, content delivery network, CDN, AWS Outpost, local zone, AWS wavelength. So AWS edge infrastructure, moving cloud closer to the endpoint. So edge is just wherever is your data, so it will put the nearby. So AWS Outpost, AWS local zone, AWS wavelength. So overview is a AWS infrastructure. So AWS Outpost is a AWS infrastructure and service on premises. AWS local zone, AWS infrastructure service in the large metro center, and AWS wavelength is infrastructure and service CSP 5G network. Use case migration. So AWS Outpost is a migration, local and critical application data residency, and AWS local zone is migration, also low latency and local data processing, and AWS wavelength is ultra low latency local data processing. So AWS wavelength is very fast. Low latency means it's very fast. And service model, expandable capacity in the customer data center, co-location on premises location, AWS Outpost, and AWS local zone is scalable capacity AWS managed service facility, and AWS wavelength is a scalable capacity CS data partner managed and supported by AWS. Three way to interact with AWS. So there are three ways we can interact with AWS. First one is very simple, is the AWS management console, which is a web browser we can use, easy to use graphical interface. Second one is AWS command line interface, which we call CLI. AWS, using Unix, you type AWS, then S3 and LS. Access the service by discrete command, like LS is a list of file system, and software development kits. So SDK, access service in your code. So let's go about compute. So EC2. So EC2 means Elastic Compute Cloud. EC2 means Compute Cloud. EC2. So EC2 is a resizable output capacity. Compute control your computing resources. Reduce time required to obtain and boost a new server instance. Virtual machine versus physical server. There is a virtual machine VPC and physical server. So what is the difference? Amazon EC2 can solve some problems that are more difficult with on-premises service when you're using disposal resources. Like sometimes you need very high resources. So data-driven decision, quick iteration, free to make the mistakes. EC2, your AMI, then instance, how many instances you need. And so Amazon EC2 provide pay-as-you pricing, board selection hardware. Use Amazon machine called Amazon machine image, AMI. Add terminate instance as you need. Pause and resume your instances. So if you see here, first one is terminate, second one is use, third one is your EMI some is forge. Storage volume, template for storage volume, law premises, block devices. Example: application server, web server, database server, game server, mail server, media server, catalog server, file server. Benefit of EC2: it's the first one is elasticity. It's very fast with the application on demand, so it's very elastic. Second one is a control is very easy. Third one is very flexibility. Choose the instance type. Flexible means different kind of instance, CPU, and depend upon your processing engine. We need somewhere we need more CPU, somewhere more GPU. VPC integrated with the VPC, ELAB auto scaling, and it's very reliably because data is and it's very secure. It's very inexpensive. It's very easy to use. So Amazon EC2 instance family and names. Choosing the correct type of very important for efficient use your instance and cost reduction. MP5, C5, and so this is our instance family use case. So if you have 3D visualization and machine learning, we usually use GPU, and which will come under P3, P2, infra, G4, G3, F1 accelerated computer. If you use data warehousing, log data processing application, then we use EG1330EN D2H1. If you high performance database, distributed memories, cache, then we use X and XE and ZDR5. If you use high performance web server, video encoding, compute optimized, use CF5, C5 and C4. Low traffic website and web application, small database and medium size, we use general purpose A1, T3, T3A, T2. So these are classification. Now Amazon EC2 pricing. On demand instance, reserve instance, saving plan, spot instance. Pre-second billing Amazon Linux and Ubuntu only. Per hour billing is all other OS. Unmanaged versus managed service. So unmanaged means you manage scaling, fault tolerance and availability. Managed means scaling, fault tolerance and availability typically built in the service, so Amazon will manage. What is serverless computing? Let's talk about serverless. Building and running application and service without managing services. You don't care about server, so that's called serverless. But actually, behind the AWS will run the server. No servers to provision, manage, scale with the use. Never pay for ideal availability and fault tolerance for build. AWS Lambda. So this is also very fully managed compute service. Run stateless code, support multiple languages, runs your code scalable in the response of event, change to data, Amazon S3 bucket or Amazon DynamoDB table. So Lambda example of create thumbnails. So use the upload a full size, and then we have full size image. Then we source bucket. In Amazon S3 send event to Lambda function when the object is created. And now the Lambda will decide target bucket. Lambda function resize image and upload thumbnail to target bucket. No server to provision, manage Lambda function. So serverless application use case. First is web application, static website, complex web application packet. Like static webless we can use. Backend application and service, mobile IoT, data processing, real time, map reduce, batch, machine learning. Chatbots, providing chatbot logic. Amazon Alexa, powering voice enabled application. Alexa skill kit, IT automation, policy engine, extending AWS service infrastructure management. Amazon Elastic Container Service, ECS. So it's called Amazon Elastic Container Service. Amazon Elastic Container Service, so ECS. So where to use and what is ECS? It's an execution container, maintain and scale the fleet node running your container, remove the complexity of standing up an infrastructure. So Amazon ECS, you have a lot of server. On top of server we have cluster manager. ECS. So basically this is a container which it's like a yarn in the Hadoop, and it's scheduling and cluster manager. It's do the cluster management. Whenever it's ideal, it will remove. Knowledge check, which of the following not feature of EC2? Okay, so we are just going to check the knowledge. Word selection of instance type of different workload, fully managed compute service, multiple pricing option per second billing, compute control over instance, remote access option, reusable. I think number C from my side, or fully managed compute service Lambda, which is not a feature of EC2. Okay, so let's talk about storage. So AWS storage option have, first one is S3, then Amazon S3 Glacier, then next part is they are having EFS and Amazon Storage Gateway and Amazon EBS. So S3 is a scalable, high durable object storage in the cloud. Amazon S3 Glacier, low cost, high durable archive storage. So S3 and S3 Glacier only difference is S3 Glacier is archive. Amazon EFS, Amazon scalable network file storage. So file storage system for the EC2 instance. Amazon Storage Gateway, hybrid cloud storage service that give you on-premises access to the virtually unlimited cloud storage. So this is a on-premises gateway. Amazon EBS is object storage system, network attached volume that provide durable block level storage for Amazon EC2 storage. So EC3, is the object level storage first thing, then design for 99 durability, event trigger, event based trigger, like any file come then it trigger, content storage, distribution, backup and archiving, big data analytics, disaster recovery, static website hosting. Amazon S3 built for store retrieve data, fast, durable, highly available access to object, can store unlimited number of objects in the bucket, store and retrieve data anytime from anywhere in the web. So client send a request to S3, S3 check in the Amazon bucket and object to be written. Choosing in region, data residency, regulatory computation. Are there is any relevant region data privacy law? Can customer data store in the outside of country? So there is some rule like data can store in the the where the same country. Approximately of use case of data, a small different latency can be impacted customer experience. Choose your region, dataset your user. Cost effectiveness, cost vary by region. Evaluate cost effective replica data in another region. S3 Glacier, as I said before, long term data storage. It's for archival and backup, very low cost. Media assets workflow, healthcare infrastructure archiving, regulatory and compliance archiving, scientific data storage, digital prevention, magnetic tape replacement. Amazon Elastic Block Storage, which will call EBS. So you see the example here, Amazon EBS, EC2 instance, and Amazon EBS volume. Persistence block storage, for instance, protected through the replication, different drive type, scale up to down in a minute, pay only what you provision, snapshot functionality, encrypted available. So it's like block level storage, so we can do the encryption. Knowledge check, which of the following service offer the object based storage, right? Amazon Elastic Block Storage, AWS Storage Gateway, Amazon Elastic File System, S3, Amazon Machine, I think EBS. Amazon, which is following object based. Okay, so this one is block based. Okay, so S3 is a object based and EBS is block based. That's the difference. Let's talk about databases. Purpose of building database. So first one is Amazon RDS, and this is a relational database. So if you work on OLTP system, online transaction processing, so we have RDBMS, relational database management system. So typical MySQL and Postgres. Similarly in AWS we have Amazon RDS, Amazon Aurora, Amazon Redshift. So three databases: Aurora, Redshift and RDS. Next part is key value. So if you understand the key value databases where we need very high read, a large number of people are reading, we use Amazon DynamoDB. It's a key value database like HBase, and document DB is MongoDB. So Amazon document DB also they have, and non-relational in-memory database like Redshift, Amazon Elastic Cache, and non-relational graph Amazon Napster. Non-relational graph and non-relational memory is Elastic Cache and Napster, and the non-relational ledger is Amazon QLDB. So now let's talk about DIY versus AWS database service. Amazon database on Amazon EC2, operating system access, need, feature and specific application. AWS database service, easy to set up, manage, maintain, push button, high availability, focus on performance, manage infrastructure. AWS database option, transactional database, Amazon RDS, Amazon non-transactional, NoSQL, DynamoDB, this is for transactional process, data for analytical or relationship, a Redshift or Amazon Napture. In-memory database is a elastic cache. Amazon RDS, the setup and operate and scale the relational database in cloud with just a few clicks. Easy to set up. Amazon RDS scale. Amazon Aurora is a Microsoft SQL Server. MariaDB and Oracle, Postgres, MySQL. This is Amazon Aurora is same. Amazon Aurora, MySQL and Postgres compatible with relational data built-in cloud. High availability, durability, high performance. Amazon Aurora, high scalability, multiple region compatible. Amazon DynamoDB is fast and flexible NoSQL databases and fully managed and fast, consistent performance. Flexible, fine-grained access control. Amazon DynamoDB use case. So leaderboards and scoring, players, game server and leaderboards. Work well application that need extreme horizontal scaling, have simple and high volume data, need to scale quickly and within checkers, don't just need a complex join. Now knowledge check. Which of the following service can be used for deploy NoSQL workload? So NoSQL database is Aurora. We don't have NoSQL. Amazon RDS no. Amazon DynamoDB, Redshift. So I think C. Okay, so let's talk about networking. So Amazon VPC, your private network space in AWS cloud, provide a local and isolation for your workload, allow custom access control and security. So VPC is a virtual private cloud, VPC, virtual private cloud, VPC. So VPC under AWS cloud, we have VPC. VPC, we can do the day one test. Your private network space, AWS cloud, provide a logical isolation for your network load. Allow custom access control and security setting to your resources. Now we have VPC, virtual private cloud. First one is VPC, route table, then subnet inbound and outbound, then elastic network interface security, then third party host and production. Security at all layers, defense in the depth. Using subnet to divide your VPC, public subnet, private subnet, private subnet. Subnet is a segment or a portion of VPC IP address range where you can isolate group of resources. Subnet define internet accessibility. Private subnet no routing table enter can internet gateway not directly accessible from the public internet. So this is VPC, route table, network ACL, subnet, SG, network access control list, security group list. Elastic load balancing. So let's talk about elastic load balancing, which do the load elastic load, and so the user will come, the ELB will decide which from where to access data. Manage load balancing service distribution incoming application traffic across the multiple Amazon instances, container and IP address. Amazon route. So example.com, it will go to the VPC will divide. It will go to the EBS, ELB, Amazon elastic load balancing, ELB, then go to VPC. So route S3 is a highly available and scalable cloud domain name and the DNS. DNS translate domain name into IP address. Able to purchase and manage domain, automatically configure DNS setting. Provide tool to flexible, high performance, multiple routing option is available. So the putting all it's together, Amazon route 53, then it will go to the client will go internet gateway, Internet gateway is go to ELB. Elastic load balancing will decide where to go. Knowledge check. Which of the following layer in network defense is VPC? Amazon machine image, network access control list, subnet and event, security group instance, VPC route table. Let's talk about security. So security is our top priority as in the banking sector in the all the organization, and so Amazon is very secured, and security is our top priority. So designed for security, constantly monitored, highly automated, highly available, highly accelerated. Sorry. So shared responsibility model. First one uses AWS model responsibility. Second one is customer responsibility. So AWS responsibility, AWS global infrastructure, region availability zone, edge location. Then AWS foundation, compute, storage, database, networking. On top of that, customer responsibility, platform, application, identify, access management, operating system, network, firewall configuration, client side data encryption and data integration authenticity, server side encryption, network traffic protection, AWS identity and access management, IAM. So securely control access your AWS resources, assign granular privacy user group and roles, set temporary access to AWS account, federate using corporate network and with the internet identity provider. IAM is basically very important to provide your user to the groups and access control. So basically three things is here: user, groups and role. User, the person, application, that instance AWS. Group, collection of user with the identical permission. Roles is temporary privilege that entity can be consumed. So it's a permission policy. Define the permission control to AWS resource can access. I am a user, so use what user can do. User are not separate AWS account, they are user within your account. Each user have their own credential. I am a user are authorized to perform the specific AWS action based on their promises. Amazon S3 access control general. Default is owner, and then anyone else no. Private yes. Public for public, the owner public and he can access everything. Access policy owner, user A, user B not control access here. So basically three things is user, group and policy. So this is a very important part. So AWS Cloud Trail. Cloud Trail will tell who, what, when, where. API security relevant information. Track user activity and API use your AWS account. Continuously monitor user activity and record API call. Useful for compliance, auditing, security analytics and troubleshooting. Log file delivered to Amazon S3 buckets. What is AWS Trust Advisor? Service provide guidance to help you reduce cost, increase the performance, and finance, security, performance, cost optimization, fault tolerance, service limit. Knowledge check. Which is following in component is IAM? Group, bucket, user, instance, policy. I think group is there, instance, no, policy is there, user is there, bucket and instance. Bucket and instance is I think is not there. So what is the Internet of Things, IoT? And let's talk about this one small project. IoT is where the system integrate device such as a application, watch or camera, car can be connected to various applications. These connections enable to data to transfer to the from device to and bidirectional communication flow to the network. So car sent to hospital sent to all these they are sharing the data. So challenge for managing things. The task managing IoT device process number of challenge. Management updates, inconsistent interrupted network connectivity, device remote may be physically accessible, large fleet device production, low compute power, low specs device resources. So basically AWS IoT service, IoT is site wise, analytics wise, event wise, graph wise. What customer are doing with AWS IoT? improve the performance, productivity of the industrial process, remotely monitor patient's health, track the in-event level of managed warehouse operation, build a smarter product user experience home, grow healthier groups of greater efficiency, manage energy resources and more efficiently, transfer AWS IoT rapid development. So IoT will come, then AWS Lambda run code response event, AWS Lambda, Amazon Dynamic Predict and scalable NoSQL data, Amazon Kinesis streaming data analysis, Amazon API gateways build and deploy and manage APIs, Amazon Redshift is petabytes of scale data warehouse, Amazon SNS is mobile push notification, Amazon Cognito is identify and data synchronization. So cloud, AWS is green gas, problem solution. So machine learning also, what machine learning is, any techniques enable to computer to human intelligence using the logic. If the statement of machine learning include deep learning, machine learning ML, deep learning. So 400 product per minute sold in Amazon.com, 1.6 million packets every day, billions of Alexa interact with each week, first prime air delivery on December 26. AWS AI and machine learning services. So AI services we have vision, speech, language, chatbot, forecast, recommendation, ML service, ground truth, notebook, algorithm, reinforcement, training, optimization, deployment, hosting. ML fundamental is TensorFlow, so all these things, infrastructure also ready. Amazon SageMaker is a ground truth. New SageMaker is a data wrangler. SageMaker for data processing. SageMaker build, train, tune. This is for machine learning. These are some problems which using AWS we solve. Object transcends detection, facial recognition, blockchain, and use case. There are different use cases of AWS. These are use cases just I'm showing. Ground station. So please like and subscribe my channel. Thank you for watching.